starting with notation from last year, right? The first four terms of the sequence A sub n, that's because that n is a subscript, equals, and they're just giving us a rule. So if we want the first term, that's notated by A sub 1. And for the first term, if n is 1, you just plug in 1. So negative 1 to the first power over 3 to the first power minus 1. And negative 1 to the first power is negative 1. 3 to the first power minus 1 is on your denominator. Please don't make this any more painful than it's already going to be. 2. Thank you, Abby. So there's your first term, negative a half. Go ahead and find the second, third, and fourth terms on your own. Marissa, what'd you get for the second term? 1/8. Third term, Olivia? 1/26. And fourth term, Nate. Say it again. Does anybody disagree with any of those? Kenzie? Negative 1 over 26. So that means if we're plugging in a 3, that would be negative 1 to the third power over 3 to the third power minus 1. Yeah, anytime you are on an odd term, it should be negative because a negative number to an odd power stays negative. So it would be negative 1 over 26. But when you square something or raise it to the fourth, it does make it positive. So negative 1/2, 1/8, negative 1/26, 1/80th. Good? So just notational review. Here's another notational review. Write the first four terms of this sequence where A sub 1 is 5. So they're telling you your first term is 5. And then they're telling you to get your nth term, you do 3 times A sub n minus 1 plus 2. So if we were looking for A sub 2, we would be plugging in an n of 2. So that would be 3. And then A sub, the entire subscript is 2 minus 1. So that subscript will reduce to 2 minus 1, which is 1, A sub 1, which is really just going to call on the first term, right? The term before the nth term that we're on right now. So when I teach this to my Algebra 2s, I teach them to always perceive A with a subscript of n minus 1 to be, quote unquote, the previous term. So A sub n minus 1 is the previous term. Because you really don't have to plug in every single time. You just say take 3 times the previous term and then add 2. So for A sub 2, that would be 3 times the previous term, and that was 5, so 3 times 5 is 15, plus 2 would give you 17. To get A sub 3, 3 times the previous term would be 3 times 17, which is 51. add 2 would get you to 53. And then a sub 4, 3 times the previous term would be 159, plus 2 would be 161. Yes? So the two types of equations we've just looked at are recursive and explicit. Which one is the explicit? The first example or the second example? Sarah, what do you think? The first, and why? What makes it explicit? How would you describe an explicit formula versus a recursive? Correct. Very good. Explicit, you can jump right to the 157th term if you want. Versus in a recursive, you can't jump right to the 157th term because you would need the 156th. So recursive requires previous terms. And it might not necessarily be the term before. It might be 2 terms before or something like that. So requires previous term. And explicit allows you to jump right to whatever number you want. It's when you have that subscript of n minus 1 or n minus 5 or n plus 4. If your subscript is an n plus or minus anything, that's indicative of recursive. Not only that, but recursive formulas have to tell you at least one term to begin with. Like this one gave us the first term, so they always have to give you a starting term as well. All right, so this next section, you've never seen this before as far as I know in like direct instruction, although some of you might know what that means. Does anyone know what 7 exclamation point would mean to do in math? Very funny, Andrew. Oh, Bailey. Yes. Multiple. There you go. So 7 factorial is how you would read it, number 1. And what it means to do is 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, no one wants to do that. I won't make you do that without a calculator. But on your calculator, if you hit 7 and then under your math, and this is a probability thing, so if you scroll over to probability, you'll see an exclamation point, and it will do just that. 7 times 6 times 5 times 4 times 3 times 2 times 1, and it's 5,040. I'm not going to make you do that by hand. But what you will need to do by hand is something like B. Well, how, Mrs. Rahil? How would you not expect us to do 7 factorial, but you would expect us to be able to do 10 factorial divided by 2 factorial times 8 factorial? Because you're going to use the concept to simplify logically without having to do massive calculations. For example, this 10 factorial is 10 times 9 times 8 times 7 times 6 times ... all the way down to 1. And your 2 factorial is 2 times 1 times your 8 factorial is 8 times 7 times 6 times ... all the way down to 1. So because these are all multiplications, we have a lot of factors that are going to cancel. Namely, in the numerator, 8 all the way down to 1 is going to cancel with 8 all the way down to 1 in the denominator. Do you see that? So without having to do massive calculations, those are just gone. And I've got 90 up top divided by 2, which is 45. So I will expect you to use the concept to look for shortened ways of doing this. Now C, maybe adding a dimension of difficulty because there's no concrete numbers here. But n plus 1 factorial means to take n plus 1 and then multiply it by what would come next? Oh, oh boy, Hamburg schools. Should we listen to it together?
An important message from Hamburg Central School District. To hear the message now, press 1 or stay on the line. Calling from the Hamburg Central School District. Due to anticipated weather conditions and out of an abundance of Have a great day.
I heard it buzzing, and I was like, I go, Hamburg School, should we listen together to this on It's good, then we can prep. This is so fun. Yay. All right, that was fun. Okay. Okay, we'll get to it. So n plus 1 would be multiplied by what next? N. And then by? Eventually we'll get down to 1. But what's the next number under n? N minus 1. And then n minus 2. And we don't really know how long that's going to go, but it will go down to 1. Right? With integers, we can do 10 times 9 times 8 times 7, but you're technically subtracting 1 from everything. So here, when you subtract 1, just becomes n. When you subtract 1, becomes n minus 1. When you subtract another one, becomes n minus 2, and so on. We have no idea how long this is going to go on for, down to 1. On the denominator, it starts with n, so I'll just keep it nice and line it up underneath the other n, and then multiplies by n minus 1 times n minus 2 times dot, 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 all the way down to 1. So without even knowing what number this could possibly be or how many things are in between, I can just not care, because whatever they are, it's going to overlap entirely with that, and your final answer is just n plus 1. Okey-doke? So the concept of factorial is one thing, just multiplying by everything down to 1. Then using it creatively to kind of simplify things, given that you don't have a calculator, is part 2. Okie doke. All right, write the first 4 terms of the sequence. So, again, we'll just plug in a sub 1, a sub 2, a sub 3, and a sub 4. Go ahead and, Andrew, this side of the room, do a sub 1. Mackenzie, your row, do a sub 2. Marissa, your row, do a sub 3. And I'll do a sub 4. Aiden, what'd you get for a sub 1? Oh, we have to talk about this. I believe 0 factorial is similar to raising anything to the 0 power. Math. Because you're right, it doesn't make sense to do 0 when you plug in your 1. 0 factorial would be 0 multiplied by everything down to 1, but you can't go down to 1 because you're already surpassed 1, right? You're already lower than 1. So it's kind of a special case in its own right. And if it equaled 0, you're right, it would be undefined. But I'm pretty sure, it's been a year, but 0 factorial equals 1. It's like raising anything to the 0 power. Like conceptually, how do you multiply something by itself 0 times? You really don't. So there's like a special rule for that. So 0 factorial is actually 1. So 2 divided by 1 would be 2. Okay, Mackenzie, what'd you get for a sub 2? Mitch, do you agree? Okay, and a sub 3. Marissa, what'd you get? You what? Oh, okay, Olivia? You also got 4. So 2 to the third power is 8. And 3 minus 1 is 2. 2 factorial is 2. 8 divided by 2 is also 4. Yep. So something funny happens. That doesn't usually happen in sequences where we get the same number twice. Good? Any questions? Huh? All right. What's this notation? Summation notation, right? You plug in a 4, you plug in a 5, you plug in a 6, you plug in a 7, and you do what with all those terms? Add them all together. So when you plug in a 4, you're going to get 16 minus 5, which is 11. When you plug in a 5, you're going to get negative 32 minus 5, which is negative 37. Plug in a 6. You're going to get 64 minus 5, which is 59. And plug in a 7. 64, 120, negative 128 minus 5 is negative 133. And you're going to add all of these together. So we have, essentially, in the positives, we have 70. And in the negatives, we have 33, 43, 53, 63, negative 170. And what do those add together to be? Negative 100. We can't do that too without a calculator for much more than a base of 2, just because those numbers would be astronomically big. So the difference is here, last year you had your calculators, right? You just typed that in. And you have to conceptually remember what your calculator was doing all that time. All right, this one is interesting. We're starting with an I equals 1. So you're plugging in a 1 for I, and then a 2 for I, and then a 3 for I, and then a 4 for I, and then a 5 for I until you're done. But there is no I, right? So when you plug in a 1 for I, what do you get? 3. When you plug in a 2 for I, what do you get? 3. And a 3 for I, and a 4 for I, and a 5 for I. You get 3 because this is a constant function. No matter what term you're on, you're going to get 3. And so when you add all these together, it's just 3 times 5, 15. Good? And then here are a couple sequences that are being all added together that you're being asked to go back and write some sort of summation notation for. So one way that I think I like to do these is I like to look at what's staying the same versus what's changing. So what is staying the same every single term? The cubed. So something is being cubed. And that's what is changing. So that's where your variable comes in. So we'll call it, let's just call it x. X is really not a typical variable that we use here, but you can use whatever you want. And that's what we have to decide. Where is it starting? What are we first plugging in for that x value? And what are we last plugging in for that x value? John, what are we plugging in to start? What are we first plugging in for x that's going to give us the first term? 1. What are we last plugging in for x that's going to give us the last term? 7. And then just verify that we are hitting everything in between. You plug in a 1, 1 cubed. Plug in a 2, 2 cubed. Plug in a 3, 3 cubed. And yes, it appears that way. Okay? B might be a little bit different. And there are multiple options. I want you to take a minute and try B on your own. All right. Ooh. 2 of the 3 of these are the same. Then we got a different one. So here's one. Let's just see if this would work. So the first thing this person is plugging in is 0. So 1 over 3 to the 0 power would be 1 over 1, which is 1. Then you plug in a 1. 1 over 3 to the first would be 1/3. 1 over 3 to the second would be 1/9. So that seems to be working out. 1 over 3 to the third would be 1/27. And then 1 over 3 to the n minus 1 would just leave you there. So they ended at n minus 1. Raise your hand if you did that. Oh. Straight elbows. 1, 2, 3. Just 3 of you. 4 of you. 5 of you. Sarah, did you have your hand up? Okay. It does work. Here's a different one. So their equation that they're plugging into is this. So if they plug in a 1, they're going to get 1 minus 1 is 0. The negative 0 power is 0. 3 to the 0 power is their first term, 1. Then they plug in a 2. If they plug in a 2, 2 minus 1 is 1. 3 to the negative first power is 1 over 3 to the first power, which is 1/3. Very good. They plug in a 3 then. 3 minus 1 is 2. 3 to the negative second is 1 over 3 to the second. Good. The one thing I'm going to be concerned with, and we'll see if it works out, is when they plug in this final thing, will it simplify to that? So 3 to the negative, and they're replacing n with 1 over 3 to the n minus 1 minus 1. I don't know. How do we even reduce something like that? The negative exponent can be brought... Is that the same thing as that? Don't think so. So it worked for all their integers, but then they couldn't really figure out where they would have to end this. This, for the record, is the same thing as 1 over 3 to the n minus 1 power, isn't it? Right? So that, I mean, what would you have to plug into this in order for it to be this? What would you have to plug in for to this for n in order for it to become this? Just n. So if they had ended this at n, we could have salvaged that, believe it or not, because that would have been just replacing the n with n, and 3 to the negative n minus 1 is the same thing as that. Okay? And then the last person did the same thing as the first person. Who did something different? Olivia, what'd you write? So that is the same thing as this person, just you used a negative exponent, so it does look different, but it's really a quick jump without having to re-verify from the get-go. You can kind of see why that's the same thing. Anybody else? No? Okay. So if you struggled with that one thing I would say is recognize that this is 3 to the first, 3 to the second, 3 to the third, right? And so what's staying the same, this is technically over 3 to the 0. So what's staying the same is 1 over 3 to the, and then the thing that's changing each time is the power. And so I always like to focus on, just for a starting point, what's staying the same and what's changing. Okay? All right, so your homework is there. Bailey, I'll give you that. Huh.